So I think one criticism I'd have about the literature in this area is, and this is common with machine learning, people tend to pick and choose their benchmarks and their metrics based on what their model performs best on. So I didn't want to do that. We trained a bunch of different models, and what I did is I ended up taking a model that had the best performance across the combination of different benchmarks. And each of these benchmarks is also a combination of benchmarks. So it's been tested a lot of different kind of summary quality data sets or summary consistency data sets. So I think we have the best performance of these models shown here on every data set aside from the true summary data set, and that is the subset of the true data set if you read the paper, where Google's model I think has an edge on us there. But overall, we have the highest accuracy in these different data sets. Our model is also considerably smaller than the true teacher model, which is probably arguably one of the next best models out there. Our model is about 184 million parameters, so it's pretty small by LLM standards. The true teacher model is like 11 billion. Some of these other models are much smaller and of comparable size, but we believe our model is more accurate.